Teaching geotechnical course to second or third year students. Today's lecture is on compaction of soil. Compaction of soil. It is the process of reduction of the air voids in the soil with little or no reduction in the water content. This process must not be confused with consolidation, in which water is squeezed out under the action of a continuous static load. Soil compaction is extensively employed in the construction of embankments and in strengthening the subgrades of roads and runways. Reduction of voids in compaction is achieved by the following: minor particles breakage, moving particles around, and squeezing pore water around or out of the voids. Objectives of compaction: to decrease future settlements, to increase shear strength, and to decrease permeability. Compaction at low moisture content. Difficult to move particles around because pore pressure is highly negative. By effective stress principle, very high all-round effective stress. Little or no pore water are to be squeezed around or out of the voids. Compaction at high moisture content. Easy to move particles around as pore water pressure is slightly negative. Lots of energy is lost in squeezing out pour water around or out of the voids. This is the typical compaction test results. From the figure we can see that for a standard Proctor test, the optimum moisture content is around 16% and corresponding maximum dry density is around 1.73 megagram per meter cube. For the same soil, for the modified Proctor test, the optimum moisture content is around 12.25% and maximum dry density is 1.87 megagram per meter cube. Here OMC is the optimum moisture content and MDD is the maximum dry density. With all soils, an increase in the compactive effort results in an increase in the maximum dry density and a decrease in the optimum moisture content. Please note, the void ratio is uniquely related to dry density of soils. In this figure, this is the lines of optimums and this is the degree of saturation, and this is the line for degree of saturation of 60%. This is the saturation 80%. Here this is the saturation 100% saturation for density of soil 2.70 megagram per meter cube. Compaction is a function of the following four variables, that is dry density or dry unit weight, water content, compactive effort, soil type, that is gradation, presence of clay minerals, etc. Notes: compaction is a simplified but theoretically sound version of a very complicated story. MDD does not correspond to E minimum in our relative density equations. Relative compaction equal dry density achieved divided by maximum dry density times 100%. Relative compaction is not equal to relative density, and it is possible to have relative compaction greater than 100%. Laboratory compaction test. The purpose of a laboratory compaction test is to determine the proper amount of mixing water to be used when compacting the soil in the field and the resulting degree of denseness which can be expected from compaction at this optimum water content. There are two standardized soil compaction and density tests which is normally used. That is, number 1 standard Proctor test and number 2 modified Proctor test. The modified Proctor test was developed during World War II by the US Army Corps of Engineering to better represent the compaction required for airfield to support heavy aircraft. The point is that increasing the compactive effort tends to increase the maximum dry density as expected but also decrease the optimum water content. The figure shows the hammer and a mold for standard Proctor test with base. For standard Proctor test, we use a hammer whose mass is 2.7 kilo and drop height is 300 millimeter, and number of soil layers 3, number of blows per layer 25, and the compaction energy will be 596 mega kilojoule per meter cube. For the modified Proctor test, the mass of hammer is 4.9 kilo, drop height is 450 millimeter, number of layers 5, number of blows per layer 25, and the compaction energy is 2703 kilojoule per meter cube. Please note that here are the numbers are for mold A, that is 105 millimeter diameter and 115.5 millimeter height. We can calculate the compaction energy by using the following equation, that is for standard Proctor test, compaction energy equal weight of hammer times drop height of hammer times number of blows per layer times number of layers divided by the volume of mold. If we transfer the above values in this equation, we can calculate the energy of the standard Proctor test, that is 2.7 kilogram times 9.81 meter per second square times 0.3 meter times 3 layers times 25 blows per layer divided by 1 times 10 to the power minus 3 meter cube, or that is the volume of the mole, and it will be 596 kg per meter, kilojoule per meter. Standard Proctor test equipment. This is the typical standard Proctor test mold, that is base, this is collar, and that is the actual mold we have to use for standard Proctor test, and this is the hammer, and we use this hammer to compact the specimen. But nowadays we can use the automatic machine. Just we have to set the number of blows and drop height, then the machine will automatically compact the soil to their desired depth and number of blows per layer. Soil type. Grain size distribution, shape of the soil grains, specific gravity of soil solids, and amount and type of clay minerals presence. This is the typical diagram of moisture density relationships of different soils. That the number 1 is for oil graded loamy sand, number 2 is for oil graded sandy loam, number 3 is for medium graded sandy loam, number 4 is for lean sandy silty clay, number 5 is for lean silty clay, number 6 is for low silt, number 7 is for heavy clay, and number 8 is for poorly graded sand. Field compaction equipments. The compaction plant used to compact wide areas of subgrade or pressed fill are almost always rollers, of which there are several forms. This can be categorized in terms of total mass and the effective depth of soil which they can compact in a single passing. Smooth wheel roller. Probably the most commonly used roller in the world is the smooth wheel roller, and it covers 100% under the wheel. Contact pressure is up to 380 kilopascals. Can be used on all soil types except for rocky soils. Compactive effort is static weight. The most common use of large smooth wheel roller is for proof rolling subgrades and compacting asphalt pavement. Pneumatic roller, 80% coverage under the wheel, contact pressure up to 700 kilopascals, can be used for both granular and fine grain soils. Compactive effort, static weight, and kneading can be used for highway fields and earth dam construction. Tamping foot roller, about 40% coverage, and contact pressure is from 1400 to 8400 kPa. It is best suited for compacting fine grained soils, that is silt and clay. Compactive effort, static weight, and kneading. Sheep foot rollers has many round or rectangular shaped protrusions or feet attached to a steel drum. 8% to 12% coverage. Compact contact pressure is from 1400 to 7000 kilopascals. It is best suited for clay soils, and compactive effort is static weight and. Thank you very much for your attention.